So, good afternoon, everyone. The class continues from where we stopped. So far, we have considered about 2 or 3 topics altogether. We talked about sets and what set is all about. We talked about some basic terms or terminology in set. We talked about different types of set, and from there, we move on to operations on sets. We move on to operation on sets. And we also talked about different operations where we talked about intersection of set, union of set, and other operations on sets. The last time we met, we also talked about different numbers, where we talked about binary. Where we talks about different type of numbers, talks about integer, real number, natural number, rational number, complex number, and the likes. So today we'll be looking at another thing different from what we did in the last classes, and that is function. Please, you need to mute yourself and think you can see my screen. So we'll be looking at function. That is the topic for the day. And in a few minutes, I will be taking you through what functions is all about. So, functions, as we can see, I think you can all see my screen being shared with you.
Yes, sir, but it's not clear, sir. It's not clear.
I don't know.
Why is that we have our course material with us
now? Is the screen here? Now you can see. Can you see the screen better now?
No, sir. The words are not very clear.
The screen is well shared now.
But sir, we have our course material. I think we can go ahead from here, sir.
Okay, thank you. That's a good one.
Yeah,
so you can move yourself so that we have a robust class.
Yes.
Yes, it's expected that you are downloading a copy of your course material. So we'll go on with the course, with the class. So we'll be looking at functions. Functions has to do with assigning. Is talking about 2 sets, still on set. Just we are talking about sets, and in this case we are talking about a set A and set B, but in terms of functions, in which an element, a unique element in set B, is being assigned to an element in set A, and that's what function is talking about, where a unique element in set set B is being assigned to a unique element in set B. I'm on page 56 of the note. So if you look at that, we can see a function A being assigned an element in set B. So when you have F such that A is mapped to set B, that's what you call a function. All the elements in set A are called domain. The set of elements that make up set B is called codomain. Please take note of that. The element of set A is called domain. The element of set B is called codomain. So it's from set B that an element is assigned to set A. So when an element is assigned from a particular set to another set, that set is called a codomain, while the one that received the set is called the domain. So each of the elements that is being assigned is called image, as you see in the note. So when you are talking about, we have what we call function. So function strictly has to do with numbers. At least you are talking about the set A that made up of number, and you are talking about set B that made up of number. So when a unique number from set B is assigned to a unique number in set A, is called a function. And each of those elements is called image. Use of the element that is assigned is called image. Look at the example 1.1. We have let f of s equal to s raised to power 2. Now look at that s is equal to s raised to power 2. So let s, you can assume any number for s. That if you take s to be 1, substitute 1 to where you have s, you see that on the other side you still want to have 1 because we have it to be s squared. Then if you assign 2, on the other side you are going to have 4. So the number you are assigning, the f of s there is like our set A, and that is what we refer to as the domain. While the s squared on the other side is what we refer to as the codomain. So an element from those sides that is assigned is called a function. Look at another simple example. That is set of example 1.2. So let f assign to each country in the world its capital. That is, we are looking at a country with capital. So a country, Nigeria, with capital Abuja, a country, France, with capital Paris. So the capital is the capital is a set and the country is a set. So when you are matching each of the country with a set with its capital, that's what we refer to as function. So assigning like that is what we define as function. So other examples you can see in the note. Then this is a typical look at example 1.5, where we'll have let A equal to a set A, B, C, D, and set B. Please, that person should mute himself. Grace, please mute yourself. So say that is example 1.5. Let A be a set A, B, C, and D, and let B be a set S, Y, Z. You can see the map, set A and set B. That is example 1.5 now. So each of these elements, the set on the right hand side that has element S, Y side are the what we call codomain. While the set on the left hand side that has A, B, C, D are what we call domain. So each element, you can see that a set A is mapped to set Y, a set B is mapped to set S, an element D is mapped to set element Y, element C is mapped to element Z in that order. That's what we call function. So instead of using alphabet, when numbers are using are strictly function, but when you use alphabet or any other, when you use alphabet or numbers, that can simply be referred to as mapping. So mapping, the difference between mapping and function is that for mapping, it can be numbers or it can be it can be alphabets. But for function, it must strictly be numbers. That is, the set must be numbers. That's when you are talking about function. But when you talk about function, when it is a number or a set of elements, then that can be called mapping. So that's just the difference between mapping and function. For mapping and function, we are doing the same thing, assigning element from a particular set to another set. So the arrow head is on the right hand side, and those ones are called the codomain, while the one on the left hand side are the domain. So each of these elements, each of those arrows is called image. The collection of all the arrows, when you combine all the arrows together, is what we refer to as range, which we'll still be talking about later. So, and that's so. Now the next thing, that is on 3.2, we see us talking about mapping, operations, and transformation. Mapping and functions are simply doing the same thing, except for mapping, we only do this with functions. For mapping, you can talk about set of numbers, or you talk about alphabet or any other thing. But when you are dealing with function, it must strictly be numbers. Function takes only numbers. So please take note of that. So that's just the difference between the mapping and the function. You can see if the domain and the codomain of a function are both the same set, we say f of A tends to f of B. Then f is frequently called an operation or transformation. So when you map an element from one set to another, then that is actually called transformation or operation. But what you are doing is mapping, or you call it function, depends on the element being considered. But the operation being carried out is what we call transformation. So we talked about different types of function or mapping. We talk about equal function, or we say equal mapping. That is, if considering two sets, considering two functions, f and g. If f and g are functions defined on the same domain, and if f of a is equal to f of g, for every element a belongs to d, then the function f and g are equal. And we can write it as f equal to g. That is, when the element, when you have two functions now, let's say set A and B map together, set C and D map together. The function of A and B is f, the function of C and D is g. So if the elements in those sets are the same, they are referred to as equal function or simply equal mapping, depends on what you are dealing with. So there we talk about the example 2.1. So let f of s equal to s squared, where s is a real number. Let g of s equal to s squared. You can see that f of s is equal to s squared, and g of s is also equal to s squared. No matter the value you assume for s in f and in g, you will see that you are going to have the same set of number for f and g, and that is what we simply refer to as mapping. When the numbers of two functions are the same, the element that made up of the sets are the same. That's what we call equal function or equal mapping. Then I've said it now before now that we talk about range of function. When you say range, in mapping, there is an arrow that goes out from one to another. Each of those arrows, when you pick it one after, each one of those arrows is called image. But the collection of all the arrows is called range. Each of the elements is called image, while the collections of all the elements that is assigned is called the range. So that's, if you go by the definition, let f be the mapping of A into B. That is, let f map A to B. Each element in B needs not appear as the image of an element in A. We define the range of f to consist precisely of those elements in B which appear as, and the image of which appear, and the image of at least one element in A. We denote it as range. So all the elements in set B, that is on the right hand side or in the codomain, that is assigned to elements in the domain, the collection of all the elements is what we refer to as range. So you see cases of example, yeah, scale or range. So range has to do with collections of all the elements in the codomain that is assigned to an element in the domain. Then we have another types of function or mapping, which is called one-to-one mapping or one-to-one function, which you can also refer to as ejective. It's either you call it one-to-one or you call it ejective mapping. One-to-one is when element from the domain has a single, when an element in the, okay, when no two elements in the code in the domain have the same element in the codomain, is what we call ejective. That is one-to-one. There's no case where one number is being assigned to two numbers. So when there is no case of one element being assigned to two numbers, is what we call one-to-one. Let me scroll up so that you can see one of those mapping draw up. Look at this. This is a one-to-one mapping. You can see this is 1 is mapped to 1, 2 is mapped to 2. There's no case like, if you look at this other mapping here, up, like this. This is not one-to-one because you can see an element Y being assigned to A and being assigned to D from example 1.5. In that case, that mapping or that function is not one-to-one. But if you look at the example given in 2.2, example given in 2.2, you see that one element to one element, one element to one element. That is an example of one-to-one mapping. Are we together? Someone want to talk?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon. Please let
Yes,
me
sir. The screen is not clear, sir. We can't see
grab your
anything.
course material. You can also open your course material. I'm reading from the course material.
Okay, sir.
That's what we agreed on earlier. It's not, I don't know what happened. If maybe when I get back to my office, the way I used to take on the board, I will be able to do it better. But I'm only reading from the course material that is with you.
Okay, sir.
So if we open the course material down, you will be able to follow. And that's one of the things we agreed on before we started the class. So that is a good example of injective mapping or injective function. That is when one element is assigned to one element. No two elements have the same element assigned to them. And that's a good example of injective function or injective mapping. Going by the statement, let F map A into B. Then F is called one-to-one or injective function. If different elements in B are assigned to different elements in A, that is, if no two different elements in A have the same image, then that is called one-to-one mapping. Another type of mapping is what we call onto mapping or onto function, which we can also refer to as subjective mapping. So onto mapping is also called subjective mapping. It's either you call it mapping or you call it function. Now I've explained the difference between mapping and function. So now you understand what a function is. When you are dealing with just pure numbers, that there is no element, there is no alphabet, all what you are dealing with is number. That is what we call function. But when you are dealing with number or alphabet is what we call mapping. But the same system or the same type or the same discussion goes with the two, either mapping or function. So onto is also what we call subjective function. Subjective function means that all the elements in the codomain must be assigned to an element in the domain. You know what a codomain is and what a domain is. A domain is the set of elements on the left-hand side, while the codomain is the set of elements on the right-hand side. So when all the elements on the right-hand side, that is the codomain, is being assigned to an element, to one or more elements in the domain, is called onto mapping or onto functions. So cases of examples are given as follows. Only that don't have the access to board, I will have be writing all this thing on board and to be more clearer. Then we also talk about another type of function which is called inverse function. Inverse function or identity function. Identity function, which you can also call identity mapping. So you say by what we have in the note, say let A be any set. Let the function A to A, that is when you have a set A being mapped to itself, is what we call identity mapping. You have a set A on the left-hand side and you have a set A on the right-hand side. So element of set A is being mapped to element of set A from the right-hand side. That's what we call identity mapping. That is your domain is set of A, your codomain is also set of A. That means we're expecting them to have the same element. So in that case, is what we call identity mapping. That is a set A mapped to a set A is what we call identity mapping. Another type of function or mapping is what we call constant function or constant mapping. What a constant, when you have two sets, let's say set A and B, a function, a set A being mapped to a set B now, when all the elements in set A has the same elements in set B assigned to them, is what we call constant function or constant mapping. That is, all the elements in the codomain, all the elements in the domain have the same element in the codomain assigned to them, is what we call constant mapping or constant function. Like by what is written in the notes, say a function f of A onto B is called a constant function if the same elements of B belong to B is assigned to every element in A. You can see if the same element of B belongs to capital
Your
B,
friend's teacher's name.
assigned to every element in A. That's what we call a constant.
Okay, let's just put it this way now. Who is older than each other, me and the person? How do you know that he's older than me?
Please kindly mute yourself.
Being taller doesn't mean you're older.
Oh, mute yourself, please.
Being taller doesn't mean that you're probably older than me.
Class.
So maybe I'm older than him. So if I'm older than him, it means he's the one that took my name.
You started telling the story.
Please mute yourself.
He said I took someone's name. So I want to find out if at all I'm taller than, if at all I'm
Victor,
older than that
please
person.
mute
So that I'll tell her
yourself.
that it's the person that took the name, that stole the name.
Victor, please mute yourself.
Okay, I want to book someone.
Please mute yourself.
Just hold on.
Mute yourself so that we can have a seamless class. So that's what we call a constant function. Then the next type of function or mapping is what we call a product function or a product mapping. In some textbook, that product function, you can see it as composite function or composite mapping. In that case, we are talking about two functions. You can see, so let F be a map to B and G be a function B map to C. The two functions. Then the product of function F and G is denoted as F of B in A map to C. So when you have a function A map to B and another function B is being mapped to C, that's what we call product function or product mapping. In some textbook, we can also call it, that product function can also be called composite function. Please take note of that. It can also be called composite function. So when you have two functions now, a function G, A mapped to B, and you have a function G, B mapped to C. In that case, you cannot say A is composite of G. That is, A is now mapped to C. So that's what we refer to as a product function or a composite function. Going from page 51 of your course material, you see examples and you see a beautiful illustration in diagram form. You can see a set A mapped to set B and a set B being mapped to set C. So that can simply be referred to F. That is, A is now mapped to C. That's what we call a composite function or a product function. So a further example you can find on page, as example 7.1, a set A, a set B, and a set C. A set A is mapped to B, and a set B is mapped to C. So in that case, we cannot say a set A is mapped to C. So if you have to consider the composite of this function, looking at set A now, A is mapped to A, a small letter A from the set A is mapped to Y in set B. And that Y is mapped to T in set C. So in that case, you can conclude that A is mapped to T. So that's what we refer to as composite function or composite mapping. The same thing you can see on page 7, example 7.2. So example 7.2 says, to each real number, let F assign its square. That is, let F of S equal to S square. To a real number, let G assign the number plus 3. That is, let G of S equal to S plus 3. Then, so if you are asked to find G of F now, that means, G of F means that you are substituting G into F. So if you have G of F, that means that is G product of F, G product F, or F, we can have it as G of F or F of G. So if you have G of F, that means you are substituting your G into your F. But if you have F of G, you are substituting your F into your G. You can see example in page 7, example 7.2 of page 62. That gives a good example for composite function. So we still have the associative or product of functions. That is the first one we have been discussing are three. When you have two functions, you can have three functions as we have it on section 3.91. You can also have three functions. Here we have function F, function G, and function C. I mean function F, function G, and function H, and that can also be a good example for product. I mean, product function or composite function. So this is different examples can be found in the notes. Then the next types of function we talk about is the inverse of function. Inverse of function is when you have F mapped to B, so you are now reversing the order. F is mapped to B. You are not saying now that B is being mapped to, I mean, a function A mapped to B. You are now you are reversing the order. Instead of A mapped to B, you are now reversing the order to B mapped to A. Is what we call inverse function. Please note yourself. So different examples can be found in the notes. Please take your time to go through the notes. You see all these explanations there. Inverse function, when the order of the function is being reversed, it's called inverse function. So when you have a function A mapped to B and being changed to function B mapped to A, is what we call inverse function. So let me stop there so that I can entertain questions from you. So please, you can unmute yourself while I take questions from you. So we have about 5 or 7 minutes to end the class. Please, you can unmute yourself. That's just what we need to discuss under functions or mapping. You can go through your notes and see more information on this. Please, if you have questions, can I take your question one after the other? Please mute yourself so that others can benefit from your question. Please, are you raising up your hand? Please, Rukayat, do you have a question? I can see you signifying. Azan, you have
yes,
question?
Sir. Yes, sir. Good evening, sir.
Good evening. Please, we have been discussing about functions, so I don't know if you have any question.
So, I was following, but it's like you're a bit faster.
Huh?
I was following, but you're a bit fast. You're a bit fast in the lecture, sir.
Oh, sorry.
No, it's not something that we're used to. So what to follow is step by step. So when you go
sorry for that. Sorry, I'm only being conscious of the time as well. That's why I have to.
Yes, sir.
And we did not have a class last week. So sorry for that.
Thank you, sir.
And I'm not in a place where I can write on the board. I will have all this better on the board for you to. I will demonstrate better on the board for you to understand.
Yes, we observe that, sir.
For today's class, just stay with me. The subsequent class, the next week class, by God's grace, it will be with whiteboard, so you have a better understanding. So, any other question, please?
No, sir. From me. From my
okay.
side.
Peace. Are you raising up your hand? Peace, who are? Peace. Okay. So let me just stop sharing my screen for now so that we can see each other. So that is that on function and mapping. So in a kind of a recap of what I've said so far, function and mapping are actually saying the same thing in some sense. But when you are talking about functions, you are using numbers to represent you are using number as the element of your set. When you are using number as element of set, you are actually referring to function. But if you want to be general, either you are using number or alphabet, then you can simply refer to it as mapping. So mapping and function are actually saying the same thing, but only that the element that made up of those sets that shows the difference between the two. And in mapping, I mean, and in mapping of functions, we are talking about we have a domain and a codomain. And a unique element from the codomain is assigned to an element in the domain. Please, once this thing go off, that means the time is up. I will reload the thing after some minutes so that we can end the class together. So the domain, we have the domain on the left-hand side and the codomain on the right-hand side. So when a unique element from the codomain is assigned to an element in the domain, is what we refer to as mapping or function. So we have different types of mapping or function. We talk about one-to-one. That is when it is one-to-one. That is no single element is being assigned to two or more elements in the domain. When each of the elements in the domain has a unique element assigned to them, is referred to as one-to-one. And we have onto. When you say onto is also called subjective. That is, all the elements in the codomain are assigned. When all the elements in the codomain are assigned, then that's what we call onto mapping. We talks about constant mapping. That is, when all the elements in the domain have the same element from codomain assigned to them, is what we call constant mapping or constant function. We also talk about the product function, which can also be referred to as composite function. So in that case, you are talking about two or more functions. Let's say you can talk about function function F, element A, set A to map to B. You can talk about function G, element B map to C. You can talk about function H, element C map to D. You will see a kind of connectivity between the set. When you have set like that, is what we refer to as composite function. So which we can simply call, in mathematically, we can express it as F of G, or you say G of F. So when you say F of G, that means you are putting all the elements of G in F. But when you say G of F, you are putting element of G. When you say G of F, you are putting element of G, the set G, the function G in F. The examples are in the note for you. I think the example can be found on, that is example 7.2 or 7.3. Explain the mathematical solving for composite function. That is F of G or G of F. So when you say G of F, you are substituting function G into F. When you say F of G, you are substituting function F into G, and you just simplify and do the calculation. And that's what you mean by composite function. Then we also talk about inverse functions. When you say inverse, that means when you have a function A mapped to B, and you are now reversing the order, that is, the function is now B mapped to A. That's what we call an inverse function. And that is what we have been saying so far since the reception of the class this evening. So if you have any questions, you can I can still take your question before the time is up. However, once the time is up now, we are going to be logged out. So for a few minutes, I will come up again so that if the time catch up with us, so that we can still have a chat or a discussion pending time. But in the absence of question, once the team log out, then that brings us to the end of the class. So if you have questions, please, I'm ready to entertain your question. You can unmute yourself to ask your question. The video discussion will be uploaded to the website for you to access after the class.
Good evening, sir.
Yes. Yeah,
yes, sir. So my question is in this product function. The product function in example 7 of 2.
Yes.
Can you throw more light to it? I'm finding it difficult to understand.
So in example, you are
7 of 2.
You are going to have two functions, maybe F and G. F will not be a map of A to B. G cannot be map of B to C. There will be a connecting set between the two functions. So when you have that, then there is no way for me to write, but don't worry, the next class I may give room for questions so that I can write on the board. Is that taking? But what that thing is saying is, when you say F of G, you are substituting the function of F in G. When you say G log F, you are substituting the function of G in F. And that's the simple mathematics calculation. If you do that, once you substitute, expand, and simplify, that will give you the composite or the product function that you are looking for.
Okay, thank you, sir.
But if you see don't clear, maybe next class,